Hi everyone. I'm excited to introduce my first Capstone project focusing on ECM, ARMN monitoring, which stands for ECM availability, reliability, and maintainability monitoring. This project is derived from my previous experience to my former company, where we identified a crucial need to enhance the performance monitoring of our ECM devices. For those who may not be familiar with ECM or electronic countermeasure, it is a vital military equipment utilized to disrupt radio frequency signals, particularly to counter threats such as drones and IED attacks. And before I jump into these Power BI reports and show to you all the metrics that I've done, I would like to dive in first the process on how I built this project. So our primary objective with this project is to significantly improve and closely monitor the availability performance of ECM devices, recognizing their critical role in safeguarding against emerging threats. Before delving into the project's specifics, let me outline the six key elements we focus on. So, insights. First, we clarify the project's objectives to ensure the clear understanding of the desired outcome, and we also include the governance to establishing frameworks for quality assurance, integration, and security protocol. And then the data, we identify and classify the necessary data source, properties, and fields crucial for meeting our objectives. And after that, the process, we define the data collections methodology, performance monitoring matrix, and analytical processes, and also we involve also the people or assign roles and responsibilities to ensure smooth project execution and accountability. And then the last part, selecting of technology, uh, we check appropriate technology for our data storage, processing, analyzing, and reporting visualization. With the objectives set, our initial step was to assess the required data. We meticulously analyzed eight distinct data sets, including uh, we conducted comprehensive data grading and gap analysis. This involves determining the relevant of each fields and attributes within the datasets, followed by constructing of a robust table schema outlining data types. So this is the data, the data schema that we use. We combine all important attributes and fields from different data sets. And then after that, uh, the next is we establish protocols for data processing. This included the diversing methodologies for data extraction from customer and derive essential metrics, in which is include the integrated logistics support formula, and then to address the challenges in direct data collections from ECM devices, we strategically employed Microsoft SaaS tools our high-level architecture leverage the SharePoint as our secondary storage, seamlessly integrated to Dataverse, uh, and establishing crucial relationship between dimension tables. And after that, we integrated to the Power BI, in which is all analytical metrics were meticulously defined. I will show you later on. Uh, and yeah, this is the high level of architecture we use in our project. So this is our the process that we did from data source. We collect the data remotely through our device, and then we have also Happy Fox here, which is a web applications, but I will not discuss this here as it's also a part of the high-level architecture, in which is I will show you later. And yeah, data integrity integration. We use data flow and Power Query Online to do the ETL process. Then we stored it to Dataverse, and then after that one, we pull the data to read on Power BI and Power Apps or Excel as an options. So to give you more context on my project, the ECM ERM monitoring, in here we have three different inputs from customer, and then we use SharePoint as temporary storage. Since SharePoint has limitations and it is not a database, we pull the data using data flow. So from data flow, we connect it to Dataverse. So in here, the ETL process has been done here using the Power Query Online inside Dataflow. And we clean the data, we check all the data types, and then map the data. And then after that one, in Dataverse, we already have now a tabular table, in which is we can build also a relationship for each dimensional table. So we define also everything in here. And then after that, we connect the Dataverse through Power BI for visualization and also uh, matrix. And also, as you can see, we have also data user here. We use RDBMS, Microsoft RDBMS, uh, to pull data also for to query in a Dataverse directly also to build visualizations, and we combine it into one dashboard. So let's go back to my dashboard, and as I've mentioned earlier, uh, all of the formula here I defined in DAX language, and in here I created a calculation folder for all my calculations. First, I defined the running hours using DAX formula, and important one, the mean time between failure, and then the failure rate, and also I defined a table, DAX table, in which is it will be needed to have a relationship for the dates we received the fault, and then it's also involved the computations of how long the downtime happened on the ECM until it restored. So I use data table, date table, and then I define also a location just to show in the map uh, the the number of incident per client or per incident per country rather. And yeah, this is my uh, table. I only use sample data sets because I cannot show you the actual data sets from my previous company for confidentiality and privacy reason. So in here, as you can see, it shows the start of repair, end of repair. All of the columns here are defined from the first data schema I built. So as you can see here, yeah, this all of the data types and columns defined here is defined on my table view, and then I'll just build some relationship of my date table and location on my facts table, which is the main data sets. And yeah, as you can see, you can filter the project, but I only have one project for now. The failure rate as well, and it's showing also the how many failure and repair done to 24 ECM, and also the reliability of the device on 50,000 running hours. So yeah, and I also add some pie chart just to show you that the device is reliable for from 50 hours running hour time, and it's operational about 98.31%, and the reliability of it is 99.95%. I think that's all.